Hi everyone, I'm Abigail.
And I'm Shane, and today we'll be sharing our project on Pascal's principle, which is also known as the principle of transmission of fluid pressure. This concept connects physics to many real-world applications like car brakes, hydraulic lifts, and even airplane controls.
Pascal's principle was discovered by Blaise Pascal in the 1600s. He was a mathematician, philosopher, and physicist who was very interested in studying fluid pressure. He came up with the principle by conducting an experiment using a barrel and a long, thin pole. The barrel was full of water, and the pole was placed inside and then filled with water as well. The pressure caused by the pole made the barrel burst. Pascal concluded that the pressure remained the same throughout the system. Pascal's principle helps explain how a small amount of force applied to a fluid can create a much larger force somewhere else in the system. Our goal is to understand how this works and to demonstrate it with our own small-scale model.
Pascal's principle led to the hydraulic press. The principle states that the force applied to one side of the system is equal to the pressure multiplied by the area of the other side. The pressure remains the same throughout the whole system, so the force that is exerted on the other side of the system, normally with a larger area, is much larger than the force initially applied to the smaller input side. To model this principle, we decided to make a small hydraulic pump using two 20 milliliter syringes, two 60 milliliter syringes, and tubing. We will set it up by connecting the small syringes to the large syringes using the tubing. For weights, we used various objects that we found around the house. The cross-sectional area of the 20 milliliter syringe is 0.515 inches squared, and the area of the 60 milliliter syringe is 1.131 inches squared. This means that the force applied to the smaller syringe should result in a force 2.196 times larger on the 60 milliliter syringe.
The average force a female can exert with her thumb is about 22 pounds. Using the formula F2 equals A2 over A1 times F1, you get F2 equals 1.131 inches squared divided by 0.515 inches squared times 22 pounds, which makes F2 about 48.314 pounds. We can also calculate the pressure within the system using the formula P1 equals F1 over A1, which gives you P1 equals 22 pounds divided by 0.515 inches squared, which means P1 is about 42.718 pounds per inch squared. Since the pressure remains the same throughout the whole system, the pressure is 52.718 pounds per inches squared.
In the end, our hydraulic lift was able to lift about 51 pounds, which means our theoretical numbers were pretty close to the real outcome. You can watch until the end to see the lift in action.